Fire safety curtains. And I don't really have an opening slide, so I'm going to go back here for a second because I don't want to get into the next batch of slides until we're ready. But we're going to talk about how to use them and how to maintain and use, test, that kind of thing. This is if there are installers amongst us. I wasn't planning on talking about installation and some of the tricks that I've had to learn over the years. But if there are questions that you have about installation stuff, let me know. We'll talk about it. It's fine. I don't think that this topic will run long. In fact, I suspect it'll run short, which is okay because I have another one of these to do at 4 o'clock. So I'll be scooting out of here. Quick history on fire safety curtains. They came into their own big time here in the U.S. in the late 1800s, and following a lead from the U.K. And London in particular, the West End. London having some issues with fire every once in a while. They're pretty serious about their fire protection and firefighting equipment over there. So their fire safety curtains, which are called irons, as in iron, they're pretty strict about making sure that not only that the theaters have them, but that they function and that they are shown to the audience, at least back in the day. I don't know what current regulations are, but every show that I have seen in the West End has had the iron in at some point. We have been shown that they have a functioning fire safety curtain.
That is still the practice.
It is still the practice. Okay. All right. It was the practice, and it came over here. We certainly had our share of fires in the U.S., and that practice came over here. As I say, in the late 1800s is when fire safety curtains started to become really common. And yes, they were required. It was a municipal, it wasn't, a state or a federally mandated thing. It was a municipal regulation that you had to show to the audience. You had to show, look, we got a fire safety curtain. So if our gas lights backstage catch fire, we'll be able to protect you, that kind of a thing. And what that did, because they were showing the curtain to every audience, it became a marketing product, a marketing plan for the theater and for the merchants in the area. They would paint scenes on the fire curtain because they were, they're going to bring it down. So let's show the audience what we got. And what happened was the scenery was absolutely stunning. It was astonishingly good. And unfortunately, it was painted on an asbestos curtain. And in many cases, they had the word asbestos written in really big letters right across the center of the curtain because they wanted everybody to know that they had an asbestos curtain. That doesn't go over too well anymore. And a lot of asbestos fire safety curtains have been removed, and regretfully, a lot of really, really stunning scenic artistry has gone into the hazmat dump. I've got some pictures I want to show you of some that either have been saved or they got pictures of them before they trashed them. This one is from the Bucks County Playhouse in Bucks County, Pennsylvania, just north of Philadelphia. And this one, they did a renovation of the theater. I want to say 3 or 4 years ago now. They talked the people, whoever the AHJ was, they talked them into allowing them to encapsulate the asbestos fire safety curtain, which is what you're looking at. So they saved it, and it's still in the theater because, well, the theater itself is a historically registered building, so I think that helped them in keeping the asbestos curtain in place. But as you can see, it's stunning. Let's see if I can get, probably going to pixelate out by that point. But this is a scene of the area. The playhouse is right on the bank of the Delaware River, which is quite large up in that part of the state, quite wide. And it was a mill town, as I understand it. Whew. Then there's this one. Let's back that one off a little bit. Yep, everybody's going to heaven in this one. But again, it's an asbestos curtain, and look what they painted on it. It's absolutely, it's incredible. And just out of curiosity, and I don't mean to throw you under the bus, Sarah, but you're the scenic artist that I know here. What would you think you would have to prep the asbestos fabric to be able to paint on it like this?
Oh, I'm sure it was all kinds of deadly things.
Okay.
It probably was aniline dyes and
Right.
lead paint, you know, nothing that you'd want to breathe, that's for sure.
Yeah. Let's see, I got a couple more here, and then we'll get into this one. Yeah, look, it says asbestos down at the bottom. And we have merchants taking out advertising. I'm sure they sold them, and you know, I'm sure that Slam Clothing and Shoes was really happy to get that spot there right underneath the lake. Cool stuff. I don't know if this one is still in existence. We've had to take out several over the years, and you know, it's really sad. You know, you're taking down this beautiful curtain, and off to the hazmat it goes. I apologize. I used to know where this one was, but I forget. And I think I have one more. Yeah, that's that one. That's not a scenery. That's not painting. That is the Iroquois Theater after the fire in 1903, I believe. Roughly 600 and some people were killed in that fire. After the fire, as is often the case, after the fire, the fire safety regulations were not only beefed up and made more stringent, but they were actually enforced. They did not do that in prior to. I do not know if the fire safety curtain, if the fire curtain was deployed in that particular fire. I don't have that information. Okay, I'm going back to the chat here real quick. Thank you, Michael, for the link to more curtains. That's great. So here's the story about fire safety curtains and what they are supposed to do, what people think they're supposed to do, and what they actually do. Yeah, it seems that you know, the public thinks that a fire safety curtain is there to allow time for people to get out of the auditorium and not burn to death, and you know, for people to get out of backstage, I suppose. Although I don't think that the public out in the house are worrying about that too much if there is a fire. And that is a secondary, I've lost the word, secondary requirement for a fire safety curtain. It's not its main purpose. The fire curtain's main purpose is to restrict the flow of fuel from the uninvolved area into the involved area. And by fuel, we're talking oxygen. If there's a fire on stage You want your fire curtain to come down in an appropriate manner, and you want it to seal the proscenium opening so that you don't get, let's just say, assume that the fire, the fire is on stage. You don't want oxygen flowing from the house onto the stage because it's just going to feed the fire. There is an additional piece of equipment which we might as well touch base on now that is used in conjunction with a fire safety curtain, and those are smoke doors. And smoke doors are in most theaters, or different styles. Certainly, the older theaters, the late 19th, early 20th century theaters, they had a cupola kind of a thing on the roof with doors that would fall open, with it slide open if they were tripped. And the theory there was you wanted to be able to evacuate all the built up heat and gases and stuff coming from the fire that were rising up in the stage house. And that's a really good idea because you can build up a lot of pressure there, and you run into a lot of difficult situations. But that makes the fire curtain sealing at the stage floor all that more important. It's absolutely critical. So in theory, the way the scenario works, if there is a fire on stage, whether the building is occupied or not should not matter. And if there is a fire, then the fire curtain sensor, whatever device is used, and we will get into it, but whatever device is used to sense that there's a fire will trip the fire safety curtain, and that will deploy. And similar sensors will tell the smoke doors up in the roof, tell them to open at the same time. As an aside here, usually when you get those smoke doors to open, they're on a pretty heavy spring, and you will fling whatever pigeon is sitting on that door into the next county, which is kind of fun to watch. The problem being, with people who don't understand fire curtains, or more to the point, don't even know that they're there, they do things to restrict the descent of a fire curtain, and that creates a real problem. As you can imagine, you open up the smoke doors and your fire curtain either doesn't deploy or doesn't completely deploy, and the fire is on stage, then you have created a chimney. You have created a kiln, if you will. The fire is on stage and it's burning away, and oxygen is coming in from the house, feeding that fire, and the gases are going up and going out the roof, but it's being replaced by the oxygen coming from the house. This is an extremely dangerous situation, and one that you don't want to have happen. The last time that we had a fire on stage that I'm aware of that had this type of problem was, it's probably 15 years ago now, or maybe 20. High school in Framingham, Massachusetts. Fire started middle of the night, and so there was nobody there to deploy, and it deployed automatically. Fire curtain came down, the smoke doors opened up, but somebody had taken one of those portable flagpoles, classroom flagpoles, 8 foot tall with an eagle on the top of it, kind of a thing. And they stuck it in the smoke pocket. And the smoke pocket on the screen here is this grayish device here and over here on the other side. And it is the track that the fire curtain runs in. And they stuck that right in there. I mean, they were probably doing a class and they wanted to get it out of the way, and they put it in there. Look, I can hide it in here. So the fire curtain came down, jammed up on the top of the pole, and created, the other side hit the floor, but created this big angle here. So all this was open. From what I've read, the fire department was there in a remarkably short period of time, something like, 7 minutes after the alarm was sounded. And the building was already fully engaged, or that whole backstage area was already fully engaged. And the reason for it is they created a kiln, or as Cindy said, just like a backyard barbecue. Yeah, just like, without the marshmallows or the hot dogs. So, and I wanted to bring up the smoke doors early on, because I'm not going to go back to them. You need to know that they exist in your theater. And typically, if the theater was built within the last 30 years, 35 years, their typical trip mechanism is a fusible wing, for an automatic trip. They also have pull stations, but let's talk about the fusible wings first. They're up in the ceiling, up inside the door mechanism, and fusible wings, the one they use, typically anyway, are designed to separate. It's just two pieces of metal connected with some solder, and it burns through, it separates at approximately 160 degrees Fahrenheit. So once the fusible link separates, the doors fly open, and you now have air getting out of the building. They also have a mechanical release, and usually there's 6 to 9 of these doors in the ceiling. And typically what's supposed to happen anyway is the mechanical release either as individual cables is run down to the floor. I'm sorry, I just got an echo there for a couple minutes. I wasn't sure what was going on. The cables are supposed to be run down to the stage floor somewhere and gathered up and mounted on a wall, so that with a sign that says, in case of fire, pull these to open the smoke doors. That's what's supposed to happen. Unfortunately, when they get installed, the contractor putting them in never knows what's going on with them, and the smoke doors are built with usually like a 5 or an 8 foot long cable on it with a round ring on the end so you can pull it. So that's left hanging 45, 50 feet in the air, with no way to get to it unless you have a grid. And then if you want to open your smoke doors manually, in the event of a fire, you would have to climb to the grid and pull on the mechanical release mechanism. Don't recommend that. Climbing up to the hot spot of the room while a fire is starting is not a good place to be. So if you got a theater and it's got smoke doors, check and see where the mechanical release mechanisms are, where they're rigged to. And if they're not down to the floor, you want to think about bringing them down to the floor in some controlled, secure manner, because you don't want the little kids pulling on it all the time. I can tell you that, theater inspectors like my guys and others who understand the true meaning of smoke doors, if your rigging is not down to the floor, they will write it up, and they should write it up, because it's useless up in the air. The other cautionary tale I have for you is that you really do need to understand that once you test a smoke door, once you open a smoke door, whether in the event of a fire or because you want to test them, it will never close properly ever again. It's kind of a rule. They don't seal properly, and you will end up with a leak, and you won't like that. Are smoke doors required in new theaters? They are required by building codes. Yes, they are indeed required. Both the ICC and the UBC and NFPA, the Life Safety Code, they all do require smoke doors. So hang on one second here. Let me just take a quick look. Mine were manually controlled from hand crank winches on the grid. Well, Norm, that seems like a really dealing with it, don't you think? Yeah, that was a style that was in place at one point. Lots of little hand crank winches, very similar to boat trailer winches, and you know, they take too long. They take too long because you don't want to be, if there's a fire going, you don't want to be standing there cranking on a winch. You want to be out the door and in fresh air. So smoke doors exist. You should inspect them frequently to make sure that visually it appears that they are working. Putting somebody up on the roof every once in a while to make sure that nothing has happened to impair their operation. There have been times when, you know, a theater will have a new roof put on, and you know, the roofing contractor doesn't know anything about smoke doors, and they put the flashing right up to the side of the smoke door and tar it all over, and there's not a snowball's chance in hell that that door is ever going to open. Jonathan, you may require, your statement depends on area and configuration of the theater.
I was responding to the question about what it's when is it required, or are they required?
Right. And you have to be really careful with that, because the requirements are not nearly as clear in some of the building codes as they should be. And it becomes even less clear when your local fire marshal or AHJ tries to interpret those requirements. If you are having a theater built, if you're, you know, in the management design team putting together a new theater, you will want to make sure that everybody understands what building code is being used to build that theater, and what the requirements are in that building code for fire safety curtains. They do vary, and there are a number of situations where, for new construction, in certain, as Jonathan says, size of the auditorium, size of the proscenium opening, height of the stage house will determine whether you need a fire safety curtain or not. I'm not planning on going down that road today unless we need to. So hang on to that deluge system for just a moment, that comment for just a moment. Let me finish up here. I think I finished with the smoke doors. They exist. Make sure that they visually appear to be functioning, both inside and outside. I'm not going to recommend that you test them. I'll leave that decision up to you. Just understand that it's my experience that every time, 100%, every time that smoke doors have been tested, the end result was, once they managed to get them closed again, they never seal properly, and you have water issues coming in. Fire safety curtains, as I said, they started in the late 1800s in the States, and they were pretty much the same until the early to mid 70s. They were around in 73 or 74, right after Osha came into existence. The federal government came in and said, you can no longer use asbestos in general. I mean, they were clamping down on asbestos, and they clamped down on asbestos fire safety curtains. Said, you can't do that anymore. But in typical government fashion, they told us what we can't do, but they didn't tell us what we could do. We were left to our own devices on that. So I think it was 74. And, you know, my very, very, very limited research points to an architect in the metropolitan New York City area who came up with this idea of a deluge curtain. I'm kind of thinking that this person had a small apartment in New York City, and the water pressure was really low, and they always wished for a really good shower, which they could not get in their apartment. So they designed a deluge system so that, you know, at some point maybe they could get a decent shower somewhere. Deluge systems are water curtain systems. Instead of a fabric coming down and deploying and sealing the proscenium opening, you get water, lots of water. It is tripped, you know, it's activated pretty much by the same mechanism that trips a fire curtain, but instead of the drop coming down, you get water. In the early days, it was simply a connection to the water system, the sprinkler system in the building, but it was a real deluge system. It was usually a 6 or 8 inch diameter pipe that ran across the top of the proscenium opening and had holes in it. And when it was tripped, water came out, more water than you could ever think about. I don't know of a single situation where a deluge curtain was tested in real life, you know, to function properly, to seal the openings, to not allow oxygen to flow from the uninvolved area to the involved area. I don't know that it's ever happened that that's been that it's been called into action under those circumstances. I do know that they have gotten tripped on a regular basis, either accidentally or foolishly by somebody who wanted to test it. And the thing that you can pretty much plan on once you deploy or activate a deluge system is you're going to lose at least the first 10 feet of your stage. You'll need to replace all the wood. If you have a pit, it will be a swimming pool, and you'll be replacing probably the first 5 to 8 rows of seats. And as Tyler DeLong just noted, the water is putrid. It is as fetid as you can imagine. It is truly truly awful. And Eric Day says, what happens when the water runs out? It does not run out because it is connected to the city water supply system. I would imagine even in a rural setting, it's still on town water. So, somebody keeps pumping. So that water just keeps on coming. And if that happens in the middle of the night, oh boy. There was in Busch Gardens down in Tampa, Florida. The park there had and I think still does, has the Moroccan Palace, which is their proscenium theater. And over the years, it had many uses. They did ice shows, they did roller skating, they did all kinds of stuff in there. But for many years, they had a deluge system, and that deluge system was connected to the building fire alarm system, so that when somebody tripped the, pulled a handle out in the lobby, they got a deluge system going. And when that happened, all hell broke loose. And it happened about 4 or 5 times before they finally figured it out and replaced it. If you have trap rooms or downstairs dressing rooms, yeah, you're screwed. All right, so deluge curtains, I can't say that they ever worked. I don't think that they ever would work properly, because I don't care how much water is coming down. If it's coming down from 40 feet in the air, by the time it gets to the stage floor, the pressure of the air pushing against it is going to move it. And it's going to move it enough that the oxygen is going to get through. So let's leave that. Let's get back over to the fire curtain. Let's talk about some of the more technical things about it, just so we all are all on the same page. Smoke pockets are really important. The fire curtain is rated to hold the pressure pushing against it from, let's say, from the house side up against the fire curtain. When it deploys, it has to be rated to withstand 2 pounds of pressure per square foot. All right, so you can imagine what kind of pressure is pushing up against the of the fire curtain, which is why I don't think that the a deluge curtain is really going to work, because I don't think the water is going to be strong enough to resist that 2 pounds of pressure, that's pushing up against it. But that does speak to the fact that the only thing really holding your fire curtain in place are these smoke pockets. So they are not just tracks. They are a resistance device. They are holding that fire curtain in place should that much pressure be pushed against it. Modern theaters, yeah, that's not a problem. Most of the time they get put in properly. You got an older theater, especially one built before the 1980s, and those anchors used to put those smoke pockets in are going to be just about anything, lead anchors, wooden shields, all kinds of stuff you find in there, because the installers really didn't understand the principle behind them and what they were really doing. You got an older theater, you're going to want to take a look at your smoke pockets and make sure that they're capable of withstanding the kind of pressure that the fire curtain will push against, put on it. You don't want your smoke pockets falling over and then having the fire curtain flapping in the breeze, right? Because now you just exacerbated the problem. Okay. I'm not paying attention to chat. Sarah, you'll tell me if I should, okay? So, look. This diagram is for a Braille style curtain, but we'll use it for not only a Braille style, but also for what we call a guillotine. The Braille style is one where the proscenium height, not the proscenium, the building height isn't high enough to allow the fire curtain to get all the way out as a drop. So it can't remain flat and fly out and actually get out of sight. The roof is too low. So we came up with a Braille style. And in that situation, the Braille curtain, this side is showing it deployed, this side is showing it in storage. The top of the Braille curtain is dead hung, and all the rigging goes down to the bottom pipe, picks it up over down to, in this case, a hand crank winch. And those of you who have theaters with a Braille style curtain or a regular curtain that's on a manually operated winch, you know that whenever they test the curtain, you always get somebody else to crank up the winch because it takes forever. And it is an excellent workout device. So let's talk about how a fire curtain deploys and what causes it to deploy. We have, lever release line inside. It never really says fire line. Okay, I would argue with that term. That is the emergency release line. This line which goes up, over, and back down again. And what this does, this line which runs over and eventually gets to the winch, this line is what holds the fire curtain in its stored position up in the air. In a Braille situation, we do not have a so curtain stored, which is hanging on the bottom pipe. So all the weight of the curtain is down to hanging on the bottom pipe, and that's all connected to the winch. So unless there's something holding the winch back, the winch wants to let it go and let the curtain come deploy. You can't tell on this little drawing here, but what holds the curtain back, what holds the winch back, is a brake, a regular old just friction brake, and there's a handle. Was that a sneeze, or was that somebody who wanted to get in there? So there's a brake here with a handle on it. This fire release line, up, over, down, and through a bunch of other stuff, we'll get to that in a sec, and down to the brake handle. It holds the brake handle in tension. So whatever the weight is of this curtain is being held by the brake, and the brake is being held by the fire release line. Now, in this fire release line, you're going to see fusible links. And you can see the little bumps, 1, 2, 3, 4, and maybe a couple over on that side. Yeah, there it is, a little arrow for it. Those fusible links, same thing as I said with the smoke doors, 160 degrees, they burn through, they separate, separating the release line, which releases tension to the brake handle on the winch, and now allows the winch to let the curtain deploy, lets it come into the deck. We have discovered that, and NFPA has finally gotten on board with this. Their new Section 80 fire doors section will tell you that fusible links in general do not work. The only time that fusible links actually work is when if they're in a release line like this, the release line is all the way up at the ceiling, where the heat is all building up here. Even if you have just a couple of feet below the ceiling where the release line is running across, the heat just goes right past it and builds up here, and you have to wait for that fusible link to heat up to 160 degrees. You have to wait for the heat to build up on the ceiling. Meanwhile, your smoke door is opened up and they're trying to dissipate the heat. So now you have cross purposes going here. Fusible links do not work. We learned this in 2009 when we first started writing the ANSI standard for fire safety curtains, and an engineering consulting firm called Arup graciously provided us with some really detailed computer modeling of theaters and fire safety curtains. And so they burned down a bunch of theaters on the computer. And that's when we discovered that the fusible links, they just don't work. They didn't let us burn down any real theaters, regretfully. What is not shown in this drawing is a rate of heat rise detector or a smoke detector. They have shown its counterpart, which is the shore guard over here, what they're calling what this is labeled as a shore guard. And this is a much more efficient and much more predictable and dependable method for releasing a fire curtain. This is an electromagnetic device, so that as long as power is going to the device, the magnet is engaged and it doesn't release the tension. It holds tension in the line. So the fire release line in its path runs through this electromagnetic device down to the handle. So in essence, you could call it another fusible link if you wanted to. It is triggered by a rate of heat rise detector that is mounted up in the ceiling. It's usually a rate of heat rise detector, but sometimes it's a smoke detector. So this is an electronic signal that is sent from, and I don't know of any wireless ones. I haven't seen any yet anyway, but it's hardwired down to the release mechanism. Smoke builds up overhead, or heat builds up overhead to a temperature that they have determined that they like, or in this case don't like, and that sends a signal. Power is shut down, the magnet releases, which allows the brake handle to disengage, and the curtain comes down. Okay, how are we doing here? Let me run over to the chat. Eric is asking if, the fusible links are above the grid. They need to be above the grid, above the blocks at the top of the fly house. It really wants to be. If your emergency release line, if you are relying on fusible links, you want it as close to the ceiling, the roof line, as you can possibly get it. My advice would be to rig your rigging blocks for that release line. They would be hanging on the same building steel as as the loft blocks, if you know, if the loft blocks are hanging underhung from the building steel. But you need it to be up there as close to the ceiling as you can get, because that's where the heat buildup is, and you want that to trip quickly. You're not looking for a delay here, you know. Stephen asks, power outage would also cause the curtain to drop. Yes, it will. Depending on the device. The SureGuard, as they've noted on this drawing, is a brand name, and it's probably the most common release mechanism that's used in our industry. It has a battery backup, but that battery backup is probably good for about 4, maybe 6 hours when new. So, you know, if you've got a situation where you lose power at 11 o'clock at night, and nobody's coming in until 8 o'clock the next morning, yeah, you got a pretty good chance that your fire curtain will deploy. And you really don't want it hooked up to the deluge system, if you know what I mean. Michael, power's rate of rise depends on how quickly the temperature changes, not how high it gets. In most cases, yes, we are talking about a rate of heat rise. So how fast it increases in temperature. There are sensors out there that simply measure temperature, and they will alert whatever it is they're designed to alert when it reaches that particular temperature. I don't think I've ever seen one of those in a theatrical application. Right, we're going to talk, Norm brought up some good points. We're going to talk about that next. Okay, so, but you know, just to go back to the method for deploying, making sure that the curtain deploys properly. This is for a Braille system. There really is no difference here when you're talking about a straight lift curtain. Going back, I think here. Right, so we got a straight lift curtain here, which is on a counterweight system, and we have some mechanisms and stuff over here, which we're going to get into. So the fire release line works on the same basic principle as we just saw with the Braille. What we have done, however, we've added in a component to a straight lift curtain that is really, really common in, you know, recent, relatively new and older systems, and that's a counterweight system. Basically, the system functions just like any other counterweight line set. The difference being it doesn't have a rope lock, because you don't want a rope lock, because somebody will engage that lock and walk away, and that's the night you get a fire. So we have another issue to deal with here. In the Braille system, we didn't have a counterweight, but the full weight of the curtain was transferred over to the winch. So once we release the brake handle, the curtain's going to come down because the weight is pulling it down. We have a counterweight system here, so in theory, we don't have the same capability. Let me just, no, that's not going to help. All right, let me find a, sorry guys. So here's what we do. Here's what we do. I'll tell you the right way to do it first, and we'll go to the bad ways that other people have done it. To get this curtain to deploy, when that release line is broken for whatever reason, the fusible link, electronic sensor, whatever, the release line has been separated, we want the curtain to come down. So, but we have a counterweight system. So what we do, assuming for the moment that the curtain weighs 500 pounds, we're going to put 500 pounds worth of counterweight into the arbor. So now the curtain is balanced. And if you trip the mechanism, nothing's going to happen. Enter the safety chain. And that safety chain is usually there's either the same number of safety chains as loft blocks or one more. So if you got 4 loft blocks like we do here, we have 1, 2, 3, 4, 5 safety chains. Those safety chains are usually like a 3/8 proof coil chain. They have some heft to them. They have some weight to them. They are dead tied to the building structure overhead. And they are long enough to allow the fire curtain to come all the way down to the floor and then still be slack. They'll still have like a foot of slack on them. So if there's 50 feet from the ceiling to the floor, there's going to be 52 feet of chain or thereabouts. So we're dead tied to the building steel, and we're connected to the top batten of the safety curtain. So the chain hangs down in this loop and goes back up to where it's connected to the batten. Okay, and you have that, as I say, five in 5 locations. We don't balance for that. We balance 500 pounds for the curtain, so we put 500 pounds here. We don't counterbalance for the, let's say 50 to 75 pounds worth of chain weight that is hanging from the top of the curtain down to the bottom of the loop. So when you trip the emergency release line, the curtain's out of weight and it's going to want to come down. And as it comes down, it's going to start off pretty good because you're out of balance by about 75 pounds or somewhere in that neighborhood. It's going to start coming down pretty good. But as it comes down, the weight of the chain transfers to the building, so that the section hanging down from the building gets longer, and the section hanging from the top of the fire curtain gets shorter. The idea being, you get it going, you get it started, it comes down quickly, but as the weight transfers, you're getting closer and closer to being in weight with the arbor, so it's supposed to slow down and then stop at the floor, and seal right at the floor. That's what it's supposed to do. It never does that. Without any other mechanism involved, what will happen is the curtain will come down. It'll come down too fast. It'll slam into the floor, bounce. It'll pile up on the floor because of momentum and bounce back up again. And it'll bounce up a couple of feet, thereby picking up a couple of feet of chain, putting weight on the curtain again, and then it will slowly drift back down to the stage floor. And if you have weighted the counterweight and the chain properly, it'll work. It's a little dubious, but it's the best method that the industry came up with over the last 50 years. And that's the way people were doing it. These days, we're doing installations a little bit differently. We'll get into that. It's a motorized system that's typically being installed anymore. I don't think any manual systems are being installed. So it's important to remember that these safety chains, most people think that those chains are there to hold the curtain up should the lift cables burn through on the fire curtain, the ones connecting to the arbor. Frankly, if your lift cables burn through, you have other problems. The fire safety curtain is not going to be, not going to be one of them. There's other problems that you're going to have to deal with. But those safety chains, they act to initiate descent on this fire safety curtain. And by the manner in which they're rigged, they also slow it down. Okay. All right. Let's see, where are we going to go from here? That's the Braille. We did that. That's what a Braille looks like overhead. It's all bunched up. It's a royal pain in the butt because, as you can see, it takes up a fair amount of room right in a location where you're going to want to put a lot of other stuff. You're going to want to put, the show header, the number 1 electric, whatever, and that could easily be 18 inches right there. It's a lot of real estate to lose. But if you don't have enough height on your stage house, then you're going to end up with a Braille safety curtain. And oh, by the way, the basic formula that I've always used for telling an architect how tall to make the theater so that the drops will get out is that the floor to the building steel needs to be 2 times the height of the proscenium plus 5 feet. So that's the minimum. It's usually really hard just to get that. Fire safety curtain deployed. The black guy here and its buddy over there are the smoke pockets. There's one in the UK, and it's called an iron because they are framed. So it's, you know, a big honking steel frame with either asbestos or a new fabric stretched typically on both sides of it. Okay, going into the chat here for a quick second. You don't want the bounce, Eric says. Well, you know, the bounce is not good because it'll put some shock load on your grid or your building steel for sure. But if you get the bounce, you want to make sure that you get enough bounce that it'll allow the curtain to drift back down over a period of a couple of seconds. Davin says, let me read this real quick. We're going to get to that if there's time, Davin, but the quick answer to your question about having the curtain deployed when you're not using the stage is yes, you do. And that is part of the ANSI standard that we're going to get into. With the Braille curtain, would it be best to have the pipe against the front wall? So in the smoke pocket, you mean riding up, you know, you're talking about the top pipe? David, are you talking about the top pipe riding against the front wall or the bottom pipe? David, unmute, type. Okay, well, come back to me when
bottom pipe. Noted in that picture, it looked like the bottom pipe was away from the wall. Would it be best that it should be rigged so that it rides against the front wall?
Well, you don't have a choice. The lift lines are going to come down on the upstage side of the curtain, and they're going to go through rings, just like a Braille curtain, you know, like an act curtain or something that was designed to lift from the bottom. So you don't have a choice. The curtain is going to pile up and pile up on the downstage side, on the wall side. Okay, because the lifting lines and the rings are on the upstage side of the curtain. Yeah, the fabric bunch, as Michael says, it's all bunched up because that's how much fabric you got to deal with. Okay. Do I want to get into this first? Operation. I guess now is a good time to get into the operation and maintenance of a fire safety curtain. This is the ANSI standard in force for fire safety curtains in certainly in the United States. There's a couple of Canadians in the group, and I am curious to know whether you know, the Canadians have their own set of regulations, of course, and they follow building codes, either the international building codes or they follow ones that they have developed. I don't know if they follow an ANSI standard like this for a fire curtain. Just very, very briefly, remember that an ANSI standard is voluntary. You do not have to follow it. It is not legislated. It is not mandated by any regulatory body unless that regulatory body, like Osha, has identified it in one of their codes. So, you know, you have to have a fire safety curtain and you have to follow, you know, E1.22-2016. Once they reference it in their code, then it becomes law. But up until that point, it is voluntary. It is not mandatory. However, ANSI standards have the force of law in court. So if you have a fire safety curtain and you are not using it properly and you have a fire and, damage and, something, maybe somebody gets hurt or killed or something, and it all ends up in court, that ANSI standard will come into that case and it will come up and bite you. So even though that they are voluntary in nature, you need to know that they exist and you need to follow them. And the quick plug is that these are available for free from the ESTA website, esta.org. And you can download this document for free and read all about it. We're only going to touch on a couple of things. And this is the first one. I don't like reading slides, so I'll let you do it. But what this is saying is that whole concept that I just described with the safety chains, if that is the only method used to control the speed of the curtain, it does not meet the ANSI standard. You have to, you either, as it says, you've got to be in control over the entire travel, or at the very least, you have to control the last 8 feet. This is so that we don't crush our poor little actor friends, right? So we talked briefly about the mechanical brake. We saw that on the Braille curtain system. The same holds true for a straight lift. Although, as I said, in new fire curtains, they're not manually operated anymore. They are electric. They have an electric motor, but the whole principle is the same. They still function by engaging the brake until the system is activated, then the brake is disengaged and off you go. The dash pot, let's see if, well, there's a winch, manual Braille winch, a black box right here, a little handle right up there. And you stick it on the side here, crank it up for about 3 or 4 days, and then you get the curtain back up after it's been deployed. So you don't want to do that. You can see the release system here going through this is an electromagnetic release system of some sort coming down and holding on to the brake handle right here. So that when tension in this line is released for whatever reason, the brake handle is released, no more brake, curtain comes down. It's just another one. Similar device, handle, it goes in here and you crank away. I don't have a picture of a motor. Well, I do. This is a motorized system, and they're becoming more popular. And this has a dampened head block on it. So the motor is actually dampened hydraulically so that when it comes in, when the curtain comes down, the motor is controlling the descent the entire time. So, and you can adjust the speed of that curtain, through, it's back over here. But it's a hydraulic device. You can adjust the speed so it'll come down as quick as you want it or as slow as you would like it. And there's another one. All right. So instead of a motor on the floor or a crank up box on the floor, this is a manual system. So this is not an electric winch. This is a gearbox that has been dampened. To get this curtain up, you would use it, like a counterweight set. Here's the purchase line here. You would engage the brake, which is down below on the Arbor. And when the tension is released and the curtain wants to come in, the dampened gearbox holds it back, retards its travel at a speed that you can set. You want to get it right the first time, at least here, because you can see that there's nothing much to stand on to do that. Oh, okay, that's something that I wanted to show you, and we'll get to that. I am missing, bear with me here. I'm sorry, but I seem to have misplaced. Yeah, we'll get to those in a second. Those are release mechanisms. Rats, we'll get to that too. Where's my dashpot? I've lost my dashpot. Okay, rats. Okay, well, we're gonna have to visualize. Let's go back up here to this guy. Really hard to see, unfortunately. This thing is really fuzzy. There is a device connected to the counterweight arbor over on this side. Many of you have seen these. It is a metal tube that's anchored to the floor. And at the top of that tube is this big, usually like a 12-inch diameter pulley. And the rigging to the arbor runs through that. And what is going on here is that pulley is actually attached to a piece of pipe that runs inside the other pipe. So it's like it's a hydraulic piston, if you will. But in this case, instead of hydraulically forcing the piston out and using it as to create force, the hydraulic mechanism is retarding or holding back the tube, so that when the curtain comes down and it's rigged in such a way that when the curtain gets down to about 8 feet, the line running through the pulley, it tensions and starts to pull that pulley up out of the tube. And the hydraulic dampening mechanism holds it back. And you can adjust it so that you can determine how much force is required to pull the shaft and the pulley out of the hydraulic tube, and that controls the descent of the last 8 feet. They work really well when they're adjusted properly and when all the hydraulic fluid hasn't leaked out of them. They are no longer, you can still get one and use it in your new theater. Most people do not. They tend to be in older theaters in the 80s and 90s and early 20,000s. And, you use them a couple of times and the hydraulic fluid leaks out. The adjustment knob is right there in front of you. It's right visible, so anybody gets to play with it, and they do. So it's something that you need to be aware of if your fire curtain does have that device, which will control the last 8 feet of descent. You need to make sure that it's functioning properly. And eventually, because they're temperamental, they're finicky, eventually you will get fed up with it and you'll be looking to replace it with a winch of some device. I really apologize that it's not in here. I don't know what happened to it. So we were up here somewhere, right? Right. So we governed. We got the winches. Ow, stop that. Why are you giving me a hard time? And I apologize for my ineptness here, but I want to go to and show you a YouTube of a fire curtain. Now, stop. Let's get. Oh, come on. Nice, Bill. You didn't think I'd have to go through all this, did you? Oh, thank you. All right, you can see this. You can see the theater with the bright lights, right? Somebody say yes.
No, we don't have that
No.
screen up. You maybe need to share a different screen, a different window.
Yeah. Okay. All right.
Sometimes the screen you want is on another tab of, that happens to me when I teach.
Right.
So you might have a tab open, on the one page and it's on the next tab over.
There it
Is
is.
that there? It is. Okay. So hopefully we'll be able to see this. It's a little dark, and I apologize for my ineptness here. But and thank you, Judy, for the help there. This is a fire curtain deploying during a test. It is not motorized. The system is motorized, but they are not using electricity. They're not running the motor to lower it. This is an emergency run, an emergency test. Put it up. Okay. No, we don't want what's up next. So there you saw a. I'm sorry. Oh. Oh crap! I gotta get him to shut up. Hang on. No. Stop.
Is your YouTube still running?
My YouTube was still running. You couldn't hear it, but I could.
Nice.
And I was desperately looking for whoever was talking on the screen.
I ran out of people to mute.
Yeah, exactly. So I want to get back here. All right. So everybody can hear me, and we're back to the right screen, right? So what you saw there was a fire curtain coming in and controlled by the winch, but not by the electric motor. It was simply back driving through the gearbox. The motor itself was not engaged. It was for let's just call it, for sake of discussion here, it was in neutral and allowing the fire curtain to come in a controlled manner by the gearbox. Okay.
Bill, what is the time frame for that last 8 feet? I forget.
I forget too, but it's on my next screen. Let me share it up and we'll see that.
And Pamela would like to know how often these curtains need testing.
We're heading right there too. That's the next thing we're going to take a look at. All right. So to answer Michael's question, and these are sections pulled directly out of the ANSI standard. So it's section number 11-11.10. Okay. That answers your question, Michael?
Absolutely. Thank you, Bill.
Okay. And that makes that, as I said, the safety chain method that we've been using historically, it's no longer acceptable because it doesn't control the descent in any way other than by making sure that you have adjusted the weight imbalance properly. And speaking from experience, having installed my first fire curtain in 1979, it is a royal pain to get it right. So this is the weight load, the load capacity. So we're looking at 2 pounds per square foot, which over the entire area, I think the official term for that is a metric crap load. This is an important one. I'm sorry, it's not larger. There we go. When you reset it after testing, you can't be jumping through a lot of hoops, because if you're jumping through a lot of hoops to get the thing reset, that means that it's not rigged properly, and you just increase the possibility that it will not function when it needs to function. All right, let me get this a little smaller. Yell at me if I move too quickly on these. This first one should answer Pamela's question. And this is one that's a challenge for people because, you know, they don't want to do it, or they don't understand why. You know, if you're not using the theater and you have this down and you have a problem, you have a fire in the building, then you don't have to worry about it deploying because it already is. And this is this one, 12.3 is the big one. And when we do an inspection, and we determine that they haven't tested the fire curtain in the last 5 years or 10 years or whatever, or you get the deer in the headlights look of testing, you have to test them. That's how often you need to test it according to the standard. And that may sound like something terribly onerous, but it's not. And this one is the one that keeps you honest. You got to have logbooks. Speaking from experience, when there's an accident investigation and OSHA is called onto the scene, the very first thing they're going to ask for is the paperwork. And if you have paperwork, if you have a logbook, you know, and you're able to, you know, to present them with information relevant to the incident, you put yourself in a more favorable position with the OSHA folks, because now they don't have to work as hard as they might have if you didn't have the paperwork. So you're not starting, you know, at 0. You're starting at 10 and working your way up from there. But from a legal standpoint, you need logbooks, and you're going to need them regardless of this particular ANSI standard. All the building codes, they all require logbooks for machinery, you know, whether it's hoisting equipment, fire safety equipment, you know, whatever, they all require logbooks. Most people don't have them, and you know, we're working hard to get that changed. All right, what inspection? And yell at me if I'm going too quick here. Yeah. And just because I think somebody's going to ask the question, there's the definition of a qualified person per OSHA. Okay. So in our industry, a qualified person is somebody, well, somebody who is ETCP certified, for example. They would be considered a qualified person because they have that recognized degree or certificate. You know, a recognized degree, an MFA, for example, that would probably work as long as that MFA was in, you know, technical production or something. But if it was in, you know, voice coaching or, you know, acting or something, yeah, it doesn't count. And I threw in a competent person because usually people ask, you know, what's the difference between a competent person and a qualified person? And for example, in this situation, I've got a crew on site doing work. I, as the supervisor, or in my case, the boss, I can identify someone and say, you're the competent person on this particular project. And in theory, I'm picking somebody who does have that skill set. Well, I didn't think this was possible, but we're coming up short on time, and there are some things that I wanted to get to. So I'm going to keep going here for just a short period of time. Okay. Yeah, I thought I would run short. How are we doing on questions? Yeah, it is. It's very painful to explain any of the standard to most venues, but if the venue has a health and safety officer or you know, some kind of environmental safety person, somebody who's going to understand the significance of an ANSI standard, it becomes a lot easier. I tend not to try and explain an ANSI standard to a producer, but if I can get a hold of their safety officer, that's the person I want to talk with, because they understand what an ANSI standard means. And once they explain it from their standpoint to the producer, then I can go back to the producer and say, all right, this is what you have to do physically. This is what has to happen in the theater. Inspect, Eric Day. Excellent question, Eric. Inspecting the fire curtain top seal. Well, you want to make sure that it's there. And what Eric is talking about on a straight lift, a guillotine type curtain, there will typically be, well, it's actually on either, there will be across the proscenium, bolted to the proscenium wall on the upstage side, there will be a flap. I don't know how else to describe it, but a flap of the same material as the fire curtain, usually about 2 feet long, and it goes all the way across the stage, and it just hangs there. So that what happens when the fire curtain comes down, if that flap was not there, there would be a gap between the fire curtain and the proscenium wall, usually like 6, 8 inches, something like that. This flap hanging down will seal that that opening, because, you know, as the hot air tries to come up, it will push the flap up against the fire curtain. And if the seal is long enough and it goes all the way across, you know, if it's like 2 feet wide and all the way across the proscenium, it will trap the air and not allow it to come up and over the top of the fire curtain. I lost your question, Eric. Oh, there it is. You know, there's really no way to test the function of a top seal, or what we typically call it as a smoke seal. There's really no way to test the function unless you want to, you know, get some fans and bring a curtain down and then blow air up there to see if it moves properly. But you want to make sure, A, that it's there, that it runs across the proscenium all the way across this, the opening, and that it's about 2 feet long, 18 inches to 2 feet long, so that it will engage the fire curtain itself and not just kind of flap up and down. Pamela, yeah, Z-Tech, Z-E-T-E-X, actually. Oops, I sent that to, didn't mean to send that to just David. The fabric most often used is called Z-Tex, but that's a manufacturer's brand name. But they are all of the fire curtains that we are using now are basically a silica-based yarn. So it's kind of like fiberglass. Excuse me. And the smoke seal will be the same material as the fire curtain. Yeah, it's not Nomex. Thermatex, Z-Tex, Palmer has another brand name. They're all using basically the same thing, very, very minor variations. They all have to meet the same building codes, and typically they use the California building codes as their model. Okay. I want to talk about, just briefly here, I want to talk about deployment, because this is where people get a little sketchy. What do we got here? So yeah, this shows you an older style electromagnetic release mechanism here. The problem I'm seeing, and this is not an uncommon, oh wait, there it is. I wasn't seeing the sensor wire coming into it, but there it is there. We have seen any number of these electromagnetic release mechanisms mounted on a wall, and they're wired down to the trigger mechanism right here, but they're not wired to the sensor. So they're never going to work. Just people not understanding what the function is. Those of you, somebody mentioned earlier on about, cut this line. I don't think I have a picture of an actual knife. I might. Yeah, there's one. That's no longer permissible for any number of reasons. Those knives typically last about 35 minutes before somebody steals them. And if they are left hanging, they're left hanging in a grade school somewhere, and the little kiddies like to play with them and do bad things to themselves. Cutting a line is no longer allowable. It's no longer permissible in new construction. And if you're renovating your theater, you would have to remove that and put in a release mechanism, which is, similar to this. Now, this one has a double purchase fire release line. So what is going on there? Switch to another photo. And the line is coming down and going back up again. The line is running back, but there's two lines here, but you just can't see it. And in this photo, they put a pulley in there, which is what you should do, really, just to make the rigging at least a little bit more elegant. But for a manual release, you just simply pull that, and it pulls the pin and the line goes slack, and the mechanism, the winch or whatever the mechanism that this is connected to, disengages and allows the fire curtain to come down. So, if you've got those cut lines, you want to get rid of them. If you've got, like we have here, a manila line here, and they put the manila line in there so they could cut it, because using a linoleum knife to cut aircraft cable is a bit of a challenge. But that manila, it stretches, it shrinks, and You know, it's not stable enough for this, because if it stretches out and things go slack, you know, right in the middle of, you know, the second act of Macbeth, oop, did I say that out loud? The Scottish play, you know, you're going to have your fire curtain coming in. Another look at the release system. There's a little hook that goes in here. It's a pain in the butt to set. It's really operates on a hair trigger, as they say. But in the event of a fire, you want that. Okay. What else do I have over here? This is an electromagnetic release system. It's powered, it's got an indicator light, it's got a test button. So you can release the mechanism without engaging or shutting down power or any of that stuff, so that you can easily test the system. Okay. Well, you don't have to even, to answer Kino's question, the weight of the curtain is easily determined on a manufacturer's website. I apologize, I don't have that piece of information in my head. But even if you don't know who made your particular fire curtain, if it's not asbestos, if it is a newer, you know, synthetic based fire curtain, call up any of the manufacturers, go to any of their websites, find out what their fabric is on a weight per square foot or per square yard, however they do it. And that will certainly get you into the ballpark. It's not going to vary by much at all from one manufacturer to the next. They are building these they're all building them to the same set of specifications. And because they're trying to sell them, they are not overbuilding them. They're not making them more expensive to build by making them heavier or thicker or whatever. So they're all pretty much the same. This is a free end ball. This is the end of that release line mechanism when you have a counterweight operated system. You know, the counterweight arbor is at the top of this line, and that counterweight arbor wants to go out because, as we saw with the safety chain thing, the weight of the fire curtain and the weight in the arbor is the same, but we got those extra chain weight hanging, so we haven't compensated for that. So there's tension on the line, and we want to hold that back. This was the way that it always got done up until, I would say, the mid-90s, maybe. And that fire release line is coming down from the electromagnetic release station up above it, or whatever other mechanism is up above it. It comes down to the floor, goes through a pulley, and then comes up here. And I know it looks like it's tied, but it is not. That is like a 2-inch diameter lead ball. All right, gotta love the lead stuff. But it is a lead ball that the line runs through. And all you do is wrap it around the purchase line and then wrap the lead ball underneath, like we've done there. And it's held in place as long as there is tension in the line. When tension is released, the theory is that tension is released in this line will open up a little bit, the lead ball will pull out and fall away, allowing the arbor to go up, because we've been holding the arbor back. That theory works about maybe 60% of the time. If you have this particular system, there's no prohibition to using this system. You can still do it if you want. I don't think it's reliable enough to use it, and I would recommend that you replace this. The various rigging manufacturers have devices, and I think I've got one here. Yep, there's one. this is, and is there a closer shot? Yeah, there it is. Okay. So the tension is coming down from the fire release line on this side, on the left side of the device. And the cable is running up to a mechanism, or it's tied off to the arbor. I'm sorry, it goes up on that line and is tied off to the arbor, so that when you release, when tension is released, this side goes up and releases a lever on the arbor and allows the arbor to go up, and all of the mechanism stays in place. So there's nothing that you have to fall away. You're not relying on the lead ball to literally disconnect from the release line. It doesn't jam up or anything. There are a number of different methods for doing that. As you can see, this is a variation on the same theme. Tension is released here, so this lever, this arm here, just reverses position. This goes up, and there's a lever up on top of the arbor that disconnects, and off you go. Hopefully that's clear. The last thing I want to point out, and you please ask questions if you so choose, but the thing to remember, going way back to the beginning of this discussion, is that the fire curtain has to come down and seal the proscenium opening. If you have scenery in the way, if you have props or furniture or something, all right, wait, let me hang on a second. Let me answer Eric, because it pertains. Is the arbor free-flowing? The arbor is, yes, there's no rope lock on it. It is a counterweight set in the true sense of the word, except that there's no rope lock. So when you release the lever that's holding it back, it's going to go and it's going to run on its own, and you will have some other device that is retarding or controlling the rise of the arbor and the descent of the fire curtain. How dangerous is that? That is not dangerous. That is the one that I suggest, because it is extremely difficult to trip that. Where did it go? Oh, geez. I've lost it again. To hell with it. Yeah, there it is. That is extremely touchy. It's not, I wouldn't recommend it, because somebody running some scenery into that could loosen it and send it off. Kino, I'll get to that in a second. I think more importantly, I want to go back to obstructing the descent of the fire curtain. You are not allowed to do it, for the obvious reason that if you've got a sofa in the line, center stage in the line of the fire curtain, and the fire curtain comes down and hits the sofa, then you're going to have a big gap between the fire curtain and the stage, and you're going to have a lot of air flow coming through. If you do that, if you have scenery that comes through the plaster line, breaks through the proscenium or props or something, and you have not worked out with your fire marshal what to do, what alternate steps you're going to take to mitigate that problem. And if they find out about it and they come in and see your setup, they have every legal right to shut you down. And they will, say, yeah, you can't do this until we solve the problem. In many cases, solving the problem are tickets to the show. But all kidding aside, many times the problem is solved by having somebody from the fire department on a fire watch. You got somebody backstage who is there just, to deal with a fire situation. But you need to understand that if you try and fight with somebody, because you have broken the plaster line with your scenery, with a deck. Let's say you've got a deck that runs out over into your apron that is, is only 2/3 as wide as your proscenium. It's only 8 inches tall, say. Fire marshal can tell you, you gotta do something to shut that down, to close that gap. An old buddy of mine, back in the day when these theaters had money, and he was, he liked to tinker. In his theater, when he had a deck that would break the plaster line, he would design a hydraulic flipper so that a section of deck that ran in the opening there, that ran in the line of the fire curtain, was connected to this flipper. And if the fire curtain system was activated, so was the hydraulic flipper, and it would flip upstage, opening up and creating the trough for the fire curtain to come down and seal. And it worked great. And it really didn't matter whether you had scenery, props on top of it or anything, or an actor, and it would flip whatever upstage. It was fun to watch. Going back, Kino asks about recommendations regarding flame testing. A fire marshal should not be testing you're talking about your stage curtains now. You're not talking about your fire curtain, because that is that's not something that you can test without destroying it. But their NFPA 701 small scale, the revised standard, which was revised 6 or 7 years ago, is the standard that is used to test stage curtains. And your fire marshal can do it if they are trained to do it. Most fire marshals are not. There are companies out there. There are a number of companies around the country that will come in and do flame retardancy testing. Any recommendations? Well, if you've got curtains that are, the older curtains that are cotton, they do need to be tested. In theory, you should, when you bought the curtains, you should have gotten paperwork from the manufacturer that will give you guidance on when to have them retested. Whether you have to have them dry cleaned or whatever. I will tell you that typically older curtains, older cotton curtains, the problems with older curtains is not the material themselves, but the dust that accumulates on top of them. No, fire curtains don't require flame retardancy testing because it's a synthetic material, and there's nothing that can happen to it while it's in the building. It can be in the building for 100 years, I think. And it's still the same material, so you don't have to retest the curtain for flame retardancy qualities. You should have the paperwork. It should be in your logbook, so that the fire marshal or whoever's doing the inspection can make sure that that material is appropriate for the fire safety curtain. What they do require is inspection. Yeah, right. Pamela's asking about the Met. Yeah, they do a lot of things at the Met. I was involved in a number of things, but I was more involved with the fall protection stuff at the Met. And Pamela, when you ask John, please tell him I said hello. I haven't seen him other than on Facebook in a number of years. I think I'm reaching the end of what I was planning on. I don't know if I've answered all the questions in the chat. I think I have, but if you have any other questions, now is a good time to do it. Jonathan put a screenshot in the chat. What is it?
That was the dashpot.
Oh,
I
okay.
put 2 in. One but was by mistake, and the other one was the actual one.
Okay. Oh yeah, thank you. I don't know what happened to my photograph. I had it and then I didn't. Yeah, one of the other things, one of the other things to remember about fusible links, if you have an older system, and you can see a fusible link in Jonathan's screenshot, is they get old and tired. It's just a little piece of solder holding those two pieces of metal together. And the older links, they will break, and without any heat involved, they just wear out. They suffer from fatigue because there is that tension on the line all the time.
The quick links wear out?
Not the quick links, the fusible links.
Okay.
A fusible link is two pieces of metal that have been soldered together. And they're designed to melt. That solder is designed to melt at roughly 160 degrees Fahrenheit. But they're only rated for like 15 or 20 pounds. So they don't have a capacity that is usually the same. It's lower than the amount of weight we'll be putting on it in a fire curtain system. And eventually they break and the fire curtain comes down. And that happens with alarming regularity. What else we got?
Bill, if I could, I work at a school district, and my boss, our technical director, because we have to deal with crazy things like active shooters and things like that, he has decided that our fire curtain is also a device to help keep the active shooter from being able to see on stage, or if he's on stage, out into the audience. Just, it doesn't stop the bullet, but it keeps him from being able to see people. It's just one more extra use we have found for the fire curtain.
Yeah, we live in an awful world, but it's good that people are thinking along those lines. You know, to have to think about that kind of stuff is just tragic. But yeah, I get it. And that's a good idea.
Yeah. So any educators out there, that's an opportunity for you to take that into account.
Right. And if they are on stage, and if you can get them to just walk down stage a little bit, maybe you can hit them in the head with the fire curtain. Never mind. So I hope fire curtain was useful. Next week we're going to talk about truss, and Will Todd, the COO of Tomcat Truss, is going to join me, and we'll have fun, and we'll chat about lots of stuff. We will talk about how to sling a truss, because everybody wants to talk about that. Everybody has an opinion, and then we'll go on from there. So thank you all, and have a good afternoon and the rest of your week.
Thank you, Bill.
Thanks for a good session today, Bill.
Yeah, thank you.
Thank you,
Thank
Bill.
you, Bill. Got it in
Stay
stereo
safe,
that time.
folks. Stay safe.
Take care. Be safe.
Thank you, Bill.
All right, thank you.